today is our another podcast session with Hackers Unity Industry Insider. We are hosts. I am Shra to invite our guest Ankur Bhatnagar sir to be introduce themselves about their details.
Hey, my name is Ankur Bhatnagar, and I have close to 21 years of experience working into the multiple different technologies. I started my journey with the integration, and I'm an integration AI expert. I have dealt with multiple clients, talking from in different domains across the organizations. I worked in multiple different challenging customers, and I served multiple customers, being either in the retail, banking, medical, and all these different fields. Currently, I am working for Macy's. Macy's is a retail organization, and I am a staff engineer over there as well as an architect, API architect as a designation. And that's a crisp about me.
Thank you so much, sir, to introduce yourself and let's begin to be our questions forward. You have built a successful career in software engineering and progressed to be a staff engineer role. Looking back, what were the key discussions, experiences, or challenges that shaped your journey, sir? Please explain it.
Oh, that's a very good question. Yeah, so one of the biggest things that shaped my journey was learning very early in the software engineering software engineering is not just about a code. It is about solving the business problems, which basically the requirements come from the technical perspective, and how to technically challenge those requirements from a technical point of view. That is one of the most important way of doing it. We need to solve the business problem in such a way that it is reliable, scalable, and sustainable. I know these three words matters a lot into the software engineering. But early back in my career, I worked on system where the small technical choice could create a very large operational impact later. That taught me, or that think me about it, that what would be the immediate implementation, and ask bigger question: how this will scale, how it will fail, who will support this, how does it become fit into the larger architecture. Another major influence was working across different domains as per my experience. And with respect to the enterprise environment, when you work in integrations like APIs, cloud transformations, platform modernizations, you start to see the same pattern repeat again and again. So whenever you walk to a customer desk, you see the same problems like a legacy complexity, disconnected systems, security gaps, and challenging for the scaling. So those experience helped me to move from being task forced to become a system focused. So this is a very big line, which says, um, moving from a task force to a becoming a system focused. All these things, all the challenges which comes as a part of a customer journey, from a legacy complexity, disconnected systems, security gaps, and scaling challenges, solve these problems. I would also say that these challenges shaped me more toward the success. Production issues, migration issues, stakeholder agreements, disagreements, architectural trade-offs taught me all this judgment. Over the time, I realized that career growth comes when people trust your technical thinking under pressure, not just your ability to code when things are very easy. So for me, the journey was shaped by three things. One is the deep technical work, exposure to real world complexity, and learn to think like an owner rather than just an implementer. Hope that answers your question.
That's very grateful to you, sir. Technology evolves rapidly and engineers must continuously adapt. Which emerging technologies or trends do you believe will have the greatest impact on the future of software engineers? Please answer these questions about your experiences and your professional journeys experiences.
This is again a very good question. I think the biggest impact will come from the combination of an artificial intelligence, a kind of an assistant engineering, platform engineering, and secure distributed system design. So API or AI is just a technology. Artificial intelligence is just obviously the most visible trend right now. Everywhere, everyone wants to build a business scenario which talks about AI, the use of AI. But I do not think that it is a biggest impact. It is just a code generation. AI is just a kind of a code generation. It is a real impact will be in how engineers design, operate, test, document, and troubleshoot these systems. AI will help with acceleration, but it will not replace the software engineering judgment. In fact, it may increase the value of strong engineers because when code becomes easier to generate, the harder problem becomes deciding what should be built, how it should be governed, and whether it should be held up in the production. So the second big trend is platform engineering. Organizations are realizing that developer productivity does not come only from the better engineers, it comes from the better platforms. Internal platforms, standardized workflows, reusable infrastructure, good abstractions. Teams that invest in platform maturity will become faster and more reliable. The third trend is around secure, resilient, which is the most important thing in an AI ready architectures. As systems become more distributed and API driven, and as an AI gets embedded into these workflows, the business workflows or the actual business process flows, the reliability, the observability, the data governance, and the security becomes more important. The future belongs to engineers who can connect these things, not just builders, but build trustworthy systems. So overall, I would say the future is not just about new tool, it is about combining AI, cloud native engineering, and disciplined architecture to build the system that are faster, reliable, and easier to evolve. That is my take on this question.
This is very great answer. This is very helpful to all the students and also to me. It is very grateful to you, sir, that you answered about that questions. As system scale to serve millions of users, compatibility increase significantly. What are the biggest technical and organizational challenges in designing, maintaining reliable large-scale systems?
Oh, you are asking a very good question. Really, I mean, those are touching to my heart, and from the journey which I started my career back 21 years back. I mean, so these are really very good questions. So to answer this question, when you're saying system skills to serve millions of users, so I mean, at present, at a scale, the biggest challenge is that complexity stops being local. That is absolutely number one problem. A problem in one place can become a business problems in somewhere else. So the technical challenge is not just in terms of a traffic, it is a scale in terms of dependencies, changes, failure modes, and coordination. From a technical perspective, the key challenges are reliability, latency, observability, and data consistency. Once you have many services, many teams, and many integration points, failures are really isolated. A timeout in one service, or a schema dispatch in one another service, or a noisy downstream dependency can affect the entire customer experience. That is why resilience has to be built deliberately. Circuit breakers, retries, rate limiting, item dependency, fallbacks, monitoring, and strong operational visibility all matters. But honestly, from my standpoint, the most organization challenges are just as hard. At scale, systems are built by multiple teams with different goals, different timelines, and priorities. Misalignment becomes expensive if ownership is unclear, or if the team jeopardize or optimize only for their local success. The overall platform becomes hardened to operate. Governance, communication, and good architectural boundaries become essential. So reliability, large scale systems are not built by technology alone. They come from the combination of sound architecture, operation disciplines, and team alignment. In my experience, the systems that fail are not always the one which is the weakest code. They are often the one which are the weakest coordination in the entire organization. That's my thought from a perspective how the scale system scales to serve million of users complexity increase over there. So that's my take on this statement.
That's a very grateful answer to you, sir. Staff engineers are often accepted to influence technical direction beyond writing code. How do you balance hand-on engineering work on leadership, mentorship, and strategic decision making?
Oh, that's nice. So this question is something uh, mixing technical from a perspective of how you wanted to maintain the engineering work with the management. So I think the key is to understand that hands of work changes from as you grow. Early in my career back in 2000s, being hands on often means working a lot of implementation code of yourself. At staff level, being hands on still matters, but it becomes more selective and more leveraged. So for me, um, balance comes from staying close enough to the technical details that I understand that understand the reality actually behind it, while spending enough time at the architecture and strategy level to influence the right decisions. I try to stay involved in the design reviews, critical implementation paths, production issues, and technical risk. I'm not very much involved on the hands-on one's experience. But being involved in each and everywhere keeps me so much grounded. And at the same time, I spend a lot of energy on and time on alignment, helping teams make consistent choices, guiding architectures, mentoring engineers, and transforming technical decisions to the business teams. Mentorship is very, very, very important. That is the number one rule in the as a part of this balance. One staff engineer can solve one problem, but if they help other engineers think the way the staff engineer is clearly thinking, they improve the systems. They improve the systems many times more better. So I see as in mentorship not a separate responsibility but as a part of a technical leadership. Strategic decisions make also become biggest responsibility at this level. Sometimes the highest value work is not coding something yourself. It is preventing the wrong system from being built, reducing long term risk, or helping teams converge on better architecture. So I would say the balance is this: stay technical enough to the credible, stay strategic enough to be useful, and stay focused enough to be multiply the impact from the problem perspective.
You are very well answered this question. I am also to be very grateful to you, sir. Many engineers aspire to move from developer role to senior and staff level positions. What skills, habits, and mindset shift are most important for making that transition successfully? Please answer the question according to your experiences and the issues you face in your professional life. Please answer the question, sir.
Beautiful. This is a very very good. This is a very good question. Because from a perspective of a candidate, when someone starts the journey, they wanted to move to the high level roles very fast, and they wanted to move towards the leadership, to a kind of a C role in a decade or less than a decade's time. So to answer this question specifically, I will say the biggest mind shift is moving from execution to ownership. That is a fundamental thing. As a developer, we are often measured by how well we implement. As a senior or staff engineer, we are increasingly measured by how well we think, how well we influence outcomes, and how well we clarify and bring the things to the complexity. And in terms of clarity to the complex problems, I mean to say, so one important skill is architecture thinking. Everyone has to think in an architect's point of view. If someone wants you to move from a developer roles to a senior or staff level positions, we need to start seeing systems, trade-offs, dependencies, long-term consequences, not just isolated tasks. And another thing is basically the communication. Many engineers underestimate this. They work into a silo, but senior and technical roles require the ability to explain the complex ideas clearly to the audience, to the other engineers, managers, and the business stakeholders. So if people do not understand your thinking, your technical strength will not create enough impact. So the other point is habit matters a lot. Strong engineers document decisions, ask better questions, learn from incidents, and develop judgment over the time. They do not just solve one what is assigned. They notice the gaps, the risk, the duplication, and opportunities for simplification. And then there is an influence. Staff level growth is really about being the smartest person in the room. No, it is about helping the room make better decisions that influence, listening well, disagreeing constructively, mentoring others, and building trust. So I had to summarize it. The transition happens when we stop asking, how do I finish this task? And start asking, how do I improve this system, reduce future risk, and help the team succeed in the long run? That's my take on this question.
That's a very, again, great answer to you, sir. If you could share one career lesson that very inspiring software engineer should remember thought out their professional journey, what would it to be and why? How they get there? One suggestions to about to students, sir.
Oh, okay. The one lesson I would share is do not build career around writing only the code. I would repeat, do not build a career only about writing a code. Build it around solving important problems as well. See, I mean, code is very important, of course. It is our medium, how to achieve the things. But over a long career, we would not be always building up a code. I mean, or kind of a thing which keeps the metadata always alive, and you write a piece of pseudocode and keeps on working. That's very, very important. What really distinguishes strong engineers is not just how much the code they write. It is not how it is how they think. It is how they think about it. They make decisions. They handle trade-offs, and whether the systems they build continue to work well over time. If we focus only on the implementation, we may become fast but not necessarily effective. I would repeat, if we focus on the implementation, we may become fast but not necessarily effective. If we focus on understanding the problems, the users, the systems, the constraints, the risk, and the long term impact, then your engineering becomes much more valuable. That is what leads to trust, and trust is what creates opportunity. This matters because think from a perspective think from a very important perspective. If we look only from a technical standpoint, and we look from a perspective that we need to do that pseudocode should be able to generate and should be able to solve the business problem, and we are able to technically solve this problem. Does it going to increase our does it going to increase our bandwidth, what we understand as a part of an aspiring software engineer? No. The answer is simply no. It won't. It will never. This matters because careers engineers in software engineering are not built only on the technical ability. They are built on reliability, judgment, learning, and impact. These are the core pillars. I mean, whether they are on reliable, judgment, learning, and impact. So people remember the engineer who improve the system, reduce chaos, help others, and make good decision when things are unclear. So my one lesson is to the engineer who make the things work better, not just the engineer who writes the code. That mindset stays relevant at if that mindset stays relevant at the early start of the career, then the things become more easy of an operational perspective, and it becomes nice in the things. That's my stake. One advice to the aspiring software engineers right now.
That's a very grateful to you, sir, that you answered this question, and it is very helpful to be a achievement and significant impact to organization and learn to be work on that field also, and how to be get worked. And please answer one question, sir. How to be a student get more successful in career of software engineering, and please some advices to give to a student how they get their own like some certification in different fields. If anyone want to be build their LinkedIn ID, and how to be they build their a successful career, and how to get some steps and get job at quickly after the completing their engineering, and how they get influences with different media and things.
Very good. This is a combination of the two different questions. And it's a big question. So I will take a pause and I will think about it. So initially, you asked what is the for students and for the early career professionals. If they want to bring a long-term career in software engineering, what is the number one advice? Um, there are multiple things. I will go. I will go in sequential order from a perspective of the number one, number two, and number three. My biggest advice is to bring the strong foundationals. See, the technology will change, frameworks will change, tools will change very quickly, but strong fundamentals in programming, data structure, system design, debugging, network, databases, and software quality will stay value for the long period of time. We see the I have seen the era or in multiple decades the things are changing, but from a technical standpoint, if someone is clear with respect to their thought from a programming, then those things don't change much a lot. So the biggest advice is to stay very close to the technology. I mean, in with respect to the programming, the data structure, system design, debugging, networking, databases, software quality, these are the core pillars. These are the core pillars as part of my number one advice. Second, do not chase trends without understanding systems. This is the one of the weakest thing which everyone does it. They try to chase the trends without understanding the basic systems. It is good to learn tools. I'm not saying that we should not learn cloud, we should not learn AI, or we should not learn APIs. We should learn, but we should deep understand that depth matters more than the similar familiarity. There may be multiple tools available in the market, but everyone does the same job. The one tool which does the better job, we need to understand first that system, try to think, make the things more smarter towards it. So, and the third thing is get comfortable with continuous learning. This is the top notch thing which everyone wants to do it. So in software engineering, staying relevant is not just about asking anything, it is about being able to learn consistently. Even at with my experience, I devote at least 30 minutes per day to read the new technology trends or the new tool which are available in the market. See, I mean, even from a c-suite perspective, if you are at the c-suite level, I mean, you are at the management side of the project, but if you don't look from a particular perspective what is going well in the industry and what is happening into the industry and does not stay close to the technologies, then you becoming outdated. So that is the reason we have to read the case studies, we have to read the production incidents or the security vulnerability, or to see the projects which have been built, and we need to be very curious about it. The engineers who remain valuable are the ones who keep adapting without losing their technical grounding. So I would encourage early career professionals to invest in communication and professionalism very early. Learn to write clearly, explain your choices, ask good questions, and work well with others. Technical growth and career growth are connected, but they are not identical. Finally, think a long term. Do not optimize only for the next interview or just the next trending tool which is available in the market. Optimize for becoming the kind of an engineer people trust with important systems. That takes time, but what it is which create a lasting career. So that is the first question, first answers to the your question. And coming to the second and very important which thing which you said, can you share a project or an achievement that has significant impact on my organization and the lessons which I have learned from it? So one type of work that has significant impact in my career was a large scale integration and modernization initiatives, especially when multiple systems had to be connected in the secure, reliable, and scalable way. These are the three fundamental things from for when multiple systems connect across it. First is secure, reliable, and scalable. So in those kind of project, the visibility goal is usually a business outcome: faster product delivery, better customer experience, improved resilience, or support for the new digital channels. But underneath, the real challenge is often architecture, disconnected system, brittle integrations, inconsistent data flows, and the operation risk. What made those initiatives meaningful was just not delivering a one new interface or a service, but creating a strong platform development or the foundation. That included better API design, cleaner service boundaries, strong observability, improved governance, and modernization path that allowed legacy system and newer service to coexist rather than forcefully or risking or all at all one's kind of development or a kind of a replacement. The biggest lesson I learned is that high impact engineering work is really about one brittle technical component. It is about reducing friction across the system. When you make integration simpler, improve trust in platform, and create a clear path, the teams try to build on top of it. The organization move faster, very, very fast. Another lesson is that successful transformation is as much as about alignment as an architecture. The biggest design or the best design does not help if the team's stakeholders or the operational model are moving faster. So the real achievement is not only building a system, it is creating a technical foundation that the organization can definitely and confidently grow on top of it. Learning from a book or learning from implementation, they are two different aspect about a particular thing. So when you learn from a book perspective or when you learn from any of the courses which are available in the market, we have multiple platforms. I mean, be it Udemy, be it any other platforms, or a platform the LinkedIn perspective, you are learning something. But if you don't implement it or a kind of a doing a proof of concept on top of these relevant topics, then that learning becomes unnecessary, and over the period of time you will forget that. I myself, I will give you my example. My manager told me that you have to master on a corresponding AI. When the AI start evolving, that you have to understand AI and start learning AI tool which is currently going on in the market. So what I did, I mean, I simply went to the Udemy or to the LinkedIn website, and I tried to do the LinkedIn learning or the Udemy part of it, and I understand the code. And then I build a small piece of code, and from a implementation, the exercise which they have given as a part of in Udemy or the LinkedIn, but I didn't understand how this would be implemented into the production, how this would be going into an application perspective. So that is one of the major important thing which we have to understand from the get go. If we don't solve, or if we don't code, or if we don't learn from a particular perspective from a POC side how that can be implemented into our application, then that knowledge become waste. That is my thought process. Because once you do that, after 2 months down the line, if the same manager comes and asks me to do the same POC again, then I have to rebuild the same process end to end again what I achieved in the Udemy or in the LinkedIn learning website. Because those steps are very straightforward, that you have to click, you have to go on this particular web page, click on this button, generate the code, put this code into the another application, try to fire the application from an testing endpoint and see if this works. But if I would have taken that piece of code, or I have digest that particular piece of code and implement it into my POC, which is relevant to the business, then it stays very close to my heart, and then I understand the in and outs of the piece. But if I just do from a particular perspective that I take only the crisp part of it and implement it without implementing into my business implementation, then that becomes knowledge, that knowledge becomes useless. So my thought over here is, we have to make sure in such a way that the thing which we are learning, or the code which we are learning, or from any of the platform what technology we are learning, we have to implement that into the real business problems. Once you implement that into the real business problems, then it becomes a use case for your brain to understand it, that how this needs to be implemented, not just from the theoretical perspective of it. It will become and it will stay longer in your brain because you solve a business problem toward using that implementation. That's my stake on this learning perspective.
Your perspective on technology and leadership and career growth has been incredible, inspiring to us and also to me. We are very grateful to you. We had loved to hear your final message from you for students and aspiring developers who are working hard to build their career in technology, and you greatly work in your career, and we wish to you, sir, you will work like that and get progress if you think about that to get more successful in your career. Thank you so
Thank
much,
you.
sir, again.
Thank you.